So thanks for the introduction, Mark. My name's Cody Groen. I'm an agronomist at Southern Min. Today in my 20-minute talk, I'll be talking about extractable sugar per acre, some opportunities that we have at our co-op, and teasing this rollout of this new strategic ESA push that we'll be showing you guys over this coming growing season. So, figure this out. So our board's vision is to be the preeminent sugar producer in the world. What is preeminent? It's a fancy word for best, so we want to be the best. And best by what? We're benchmarking ourselves on ESA. So that's the main thing, and we want to keep the main thing the main thing. Later on, we'll be talking, coming after we roll this ESA push out, and then we're going to start talking about lowering cost to produce sugar on the farm. But for now, let's talk ESA. If we're going to benchmark against ESA, what is the starting point? What do we need to compete against? Last year, crop year 25, we saw the industry average, when you look apples to apples, was 9,200 pounds of ESA. We have obviously a shortfall with the crop that we were dealt last year, but our trajectory still leaves some room to be brought up. So we need to identify the opportunities we have so that we can get that best crop for the factory. We have the best factory in the world, we just need the best crop. And if we're looking for the best crop, what doesn't matter is almost as important as what does. So, over the last year, we've been working really hard at busting myths, or potentially confirming myths, that we have regarding this ESA shortfall, and particularly the myths that we were using to try to explain away why there's a shortfall in ESA. Many of these topics were environmental, and most of those topics were disproved. One, teasing back to one of the earlier speakers, one does have an impact some years, but the good news is we are actively working to mitigate that. This myth-busting approach did highlight some areas for opportunities that we are pretty critical that we need to focus on. So, one of the first myths, northern beets produce more sugar because of wheat. So when we're benchmarking, there's one big gorilla in the room. We compare them, they have a lot of wheat. When we look at that data though, over the northern Red River Valley, there's a couple of really stark things that pop out at us. When we look at that, we can see that if you're comparing preceding crop, the top 6 crops that the Red River Valley follows, doesn't matter which one it is. Doesn't matter that it was wheat, everything was really good. Everything is all above that 9,000 mark, and they're all within like 300 pounds. If you look, this is the data for preceding crop for the last 5 years for Southern Min. A couple things to point out. Corn, yep, corn is king. We have a lot of corn that we follow, 68%. The other thing to point out though, the range. So I mentioned that 300 pound approximate range that the Red River Valley is seeing. 300 pounds, our variation, top to bottom, 1,700 pounds, over 5x the variation. The other thing that jumps out at this data, wheat isn't the best crop here. It's not the best crop up there either. There's other crops that you can follow that yield higher ESAs. So the take-home story from this myth was it's less important what you're following, it's more important how you're following. We have another stark thing that came out in this benchmarking study. We have a lot of corn, and you guys grow amazing corn, like 20-40% better yields. If you have that kind of a yield, you're going to have a lot more residue. If you have a lot of residue, we need to be focusing on stover management and sizing that in the fall, as well as what we need to do to get a good seed bed in the spring. So we'll call that one myth busted. Next myth, beets up north get more sunlight. Theory behind this one is if they're getting more sunlight, they can do more photosynthesis. If they're doing more photosynthesis, they're putting more sugar down. So how do we answer this one? Well, we get some publicly available data with some fancy term that really doesn't mean anything to anyone, so we're just going to call it sun. So you got sun on the y-axis there, and we have the hours of the day across the x, and pretty stark observations. We got that big heap in the middle, and then, might have some smoking guns on the tails. Well, is that causing a difference? Well, not in the way that we would have expected. We see in our region, if you look at this graph, as you go above 0, that means that we're getting more sunlight. If you go below, they're up north getting more sunlight. If this was true, if this myth was true, we'd be seeing a higher sugar content than the North River Valley. These little tails on the end. Seems like it would, when you expand that over the whole growing season, you get 330 units of sun more. Just a drop in the bucket when the total that they're seeing is 87,000 or 95,000 for us. It's less than 0.5%. So the solar radiation differences in these growing years that we are comparing this data didn't contribute to the sugar difference, that ESA shortfall. So another one that we can say myth busted on. Another myth that we've heard, beets are a cool season crop, cooler Septembers, and that potential cold snap allow for better sugar up for the crops. Their theory is that there's some sort of a plant hormone that is upregulated when you get a cold snap, and that says to the beet, hey, winter's coming, we got to put sugar down. Well, the first thing that we see, how do we test this? We take all the average temperatures for the month of September, and you graph it out. Here you can see average hourly temperature across the entire month for every hour. First thing that jumps out to everyone probably is there's no real difference. So you can see both sides here, they're kind of mirroring one another. If you were going to expect to see a big sugar up for there was a big greater than 2,000 pound ESA difference. If this was true, you would expect that blue line to be bopping around somewhere down in here where it's actually cool in these years. The other observation that can be taken from these years where there was a sugar difference is Southern Maine was frequently the lower temperature of the two. Could be said that they're also the higher temperature of the two and they offset, but at the end of the day, they're only a 1 degree different between the two production regions. Unlikely that that difference of 1 degree led to any actual change or difference in sugar production. So I think we can safely say that that one is another one that was busted. Everyone here is pretty familiar with GDDs or GDUs, so I won't belabor the point, but comparing these years that we had a sugar difference between the two co-ops, we have 5,800 versus 5,300. If GDDs led to higher sugar contents, we would see them. We have 8.5% higher GDDs. This is somewhat of a interesting theory behind this. If you're more active because it's hotter, you can be more active doing more photosynthesis. You can also be doing more respiration. Well, this is busted for the fact that we're not doing more photosynthesis, but however, we might be doing more respiration. So the next myth is northern beets burn less sugar due to cooler nighttime soil. So the theory behind here is, yeah, we're warmer during the day, and that means we're both burning a little bit more sugar, just doing our normal metabolic functions, but we're also doing more photosynthesis. But then the sun goes down and we're not doing photosynthesis. Time to slow down the respiration. Just sip the diesel fuel at the generator. Don't be going full bore. How you look at this data is you would take 4-inch soil temps. That's what we did. You can see that all across the growing season. And then through a whole bunch of fancy math that I'm not going to get into today, but you can ask me afterwards and I can explain it all. You would take the whole season and you'd isolate out the hours that are at nighttime, the 4-inch soil temp, that is a good proxy for beet temperature. Then you would do a progression for a regression against what you would expect the root tonnage to increase over the whole growing season. So then you have the temperature they're at, how many tons you have. Then you can extrapolate that through an equation that says at X temperature, beets per ton lose X amount of sugar. If you do all of that fancy stuff, the end result is, yes, Southern Maine beets burned about 100 pounds of sugar more at night than the counterparts in the Red River Valley. So say it's 100 pounds, but say it cancels out. Because, yeah, myth confirmed, we're burning a little bit more sugar, but it's probably also an inconsequential myth. So teasing what Dr. Blumenfeld shared earlier, he is also the data source for this rainfall analysis. I won't spend a lot of time on this one because he kind of went over this in great detail. The next myth is beets like dry and northern beets see less rainfall. Pretty clear from what Dr. Blumenfeld was sharing that myth is busted. Yes, beets like it dry. Nobody's asking if that's a myth. We all know that beets like it dry. And yes, northern beets are seeing less precipitation. We all are also aware of the value of drain tile. Everybody's doing maximum effort to get drain tile out, so kudos there. But there's some ancillary things for this confirmed myth too that we need to go over. So the ancillary downfalls of rain. So what is unique for our growing area that is a challenge when we have higher rainfall amounts? Higher rainfall, higher humidity because of it. You combine that with heat and CLS and we have higher costs in crop protection products that have to go out for CLS, and then the CLS obviously burning up our solar panels and then using up that sugar store to rebuild the solar panels. Additionally, we have higher soil moisture because of the rainfall, and you combine that with our higher organic matter, and what this benchmarking study showed is we're somewhere in that 4 to 6 range for soil organic matter. Industry, especially the Red River Valleys, 3 to 4, 3 to 5, and elsewhere in industry, 2 or less. Well, you combine all of that, we have late season mineralization of N, and we don't see senescing, and we don't see yellowing. So others in industry don't see the same CLS pressure. Rain is a contributing factor. And others in industry do see this late season senescing or this yellowing, and rain is a contributing factor for that as well. So that's enough about the myths confirming or busting. What are we going to do about it? So we were tasked with, this past year, looking at what we were able to do for ESA and the long-term average, and what what we were going to propose to the board for our ESA strategy moving forward. So if you look at the production at Southern Bend over the last number of years, we have an ESA average of 73.92. 73.92, if we graph those in actual performance over these years and you apply a line of best fit, that would be what we would expect to project for a crop on any given year. In 2024, when we were presenting this, 2024's trend line yield was 82.85. If you multiply that by 110%, that would give a yield of 91.13 for ESA. Obviously, with what I said the industry average was for the last year, we need to up that just a little bit. The current trend line, that dotted line on the graph, we'd reach that by 2030 or 2031, but we need to move that faster, and we have opportunities to advance that timeline. So, the one thing that I want to talk about and spend a little bit of time on is harvest population. The goal that we have, everybody knows, is to bring beets to the factory, and how many? We want to bring 200 beets per 100-foot a row at harvest as the minimum. Why? Okay, we have one really exciting data set here that is amazingly linear. It's the product of tens of thousands of data points, and you can see, if you look on the left of this table, we have stand going up, and as you increase stand, we uniformly see ESA increasing all the way up to the top. So that's great. We have a really cool trend that we know that we can take to the bank. We also have an opportunity because the long-term average here is or short-term average of what we looked at for data was 181 beets per 100-foot a row is what we're bringing to the table. 38% of the acres are already over 200, but that means we have 60% of the acres that could be improved to reach that 200 recommendation. In particular, we have 23, almost a quarter of the fields are seeing harvest stands that are below 160, so a lot of room for improvement there. And I can't stand up here and give you a cookie cutter recommendation for which tactic you want to take to get a higher harvest population, but I can go over a number of the important ones. So some of the things that you guys need to be considering is seed bed. Tying back to the preceding crop discussion earlier, stover. If we have a really good corn crop, you need to be considering what do you need to do to manage stover. Fall tillage. If you did good fall tillage, or if maybe you need to do 2 spring passes or a drag pass before planting. What's your depth of moisture? How mellow is your ground? All those things are things that you need to be thinking about as you're getting out and planting your crop. Planter ground speed. I think you should be going as fast as you can and still maintain a uniform plant spacing, right? Seed spacing shouldn't be sacrificed. Should have very good spacing, because we've all seen a 210 count at harvest that has 8-inch gaps with a really big beet and a sucker beet right next to it, 2 inches apart, not doing anything. So shoot for a 200 count, nice and uniform. Cover crop, I know there's lots of trade-offs with cover crop. It's all good and fine to have that really great benefit of cover crop, but if you can't do your weed control, you're still behind. So I understand the trade-offs, but you should talk to your agriculturalist, see if there's ways that you can incorporate a cover crop still. And obviously, maybe one of the things you can do is put more seed in the ground. Maybe you want to edge on that a little bit, put a little bit more seed, and maybe you don't need to. Finally, AF and Rhizoc are stand sealers, so strongly considered lime in a Rhizoc application. That's one area we can improve. So I don't want to belittle the problems of weeds and CLS, but I will say if you're shooting for a 220 count and you achieve that and you have that really strong canopy, your weed control battle would be easier. And so the one byline, if you want to take away from it, is make your harvest count with a strong harvest count. So, yep. Next topic. So one of the opportunities that jumped out to us when we did this commission benchmarking study was the killing frost date for the Red River Valley compared to Renville. So the Red River Valley in this long-term study saw a killing frost date, or the cold snap date, of September 30th, whereas in Renville we saw October 10th. Despite that 10-day difference in typical killing freeze, we still commence harvest, main harvest, at roughly the same date. One of the opportunities that we could take advantage of is compressing harvest, making harvest faster. We delay on the front end, letting time for the beets to increase growth, increase ESA, but we would have to harvest at a faster pace so that we don't risk the backside freeze out. That risk would be really great. But the question that we'll be putting to the grower base is, should we be giving up these 10 days of growth? And then lastly, I want to close with some of the things that we're doing really good. We already see a lot of tile going out. There's maximum effort going with tile being installed, so great job there. Cover crop, we touched on that. Maybe have a conversation with your agriculturalist about what you could do and cultural practices you can implement to get cover crop. And good job, we have lime going out. Let's keep seeing that going. So with that, I'll close for any questions. Brett.
Touch on varieties compared to the Red River Valley. Are we restricting ourselves with not having a good choice of varieties? We're down to about 6 varieties in our co-op. We might develop too much.
So I think the question I think everybody probably heard Brett was, are we restricting our varieties? And I think the seed reps in the area here that can hear me will be thankful that when we did some long-term comparisons, Emma, David, Lindsay have been working on this out-of-area variety trialing, and I don't think the answer is that we need to be planting crystal varieties in our location. It's not going to be a sudden 2,000-pound ESA increase, so no, I think that was left out of here, but what we shared this summer was that's probably a myth that was busted. Other questions?